So I was the first one to get Willie, which was a Create kit, which had all the parts there. And it took me around 2 weeks to figure out you really have to plug in the cables to make it work. So, let's see. Actually, Melanie and her husband donated this old Roomba 510. Now, in Europe, they have a problem. They can't export the Create because of some sort of secret export thing. So they have to get regular Roombas and make them into TurtleBots. And it's a struggle because you don't have all the access to all the ports. So you do have a serial port. And I spent around 2 weeks trying to make a circuit because there was a circuit on the internet that said this is a circuit that worked. The circuit was wrong. And I ended up fixing it by using an Arduino bib, which just has does the USB to TTL levels is what you need. And it's pretty easy. The RX goes into the RX and the ground goes into the ground and it takes off. And it's better to use an old bib because it has a little expansion area on it. And on that expansion area you can put a 12-volt regulator, pull the power off, and now you can power the Connect. So with very rudimentary wiring, you have the signals, you have the power. And I had it up and working last week, and I actually posted the video today showing that that'll work because I know by time today rolls around, some wire will fall off and it won't work. Hopefully we'll be able to demonstrate it. One of the benefits is I'm a member of Tech Shop, so I could burn the wood plates on the laser. You just download the DXF files, put them on the laser, and away you go. And also I built the standards. It helps to have a lathe because drilling a hole in the center of a aluminum rod is very difficult if you don't have a lathe. It's possible to do it if you have a center drill. You know what a center drill is? And it's a number 29 drill and a number 832 tap. And I'm running Diamondback because they don't have the electric drivers for the Roomba version yet. The only thing in the Diamondback, you have to change the baud rate, and you have to dig through 500 Python scripts to figure out where you change that one node to get it to go to the right baud rate. And then it all works. And the other thing is the battery management on this is pitiful, so I put an extra battery on to give it a little extra power. So I have 10 minutes of runtime as opposed to 3 minutes. Okay.
Excellent.
All right.
Is your son going to demo his robot?
Oh, yeah.
Come on up here and show it up.
So this is me trying to not have to buy anything to try to balance something. So what I had is that
I can move this guy. Is that better?
Speak to the crowd.
So what I did was I just kind of cobbled together the regular balancer design and then added this ultrasonic distance sensor so that I could kind of calculate how far I'm tilted based on how far this is from the ground. And then I also wrote a PID loop from that to try and kind of balance. And I'm halfway through tuning it, so it kind of kills itself.
Notice the clever leash. Yeah, that's very good.
Like the wild leash.
It's like the wild leash. Yep.
That's a rascally robot there.
There.
Okay. Anyway.
Next time. I want him to drain the batteries. Okay. You. Okay. You'll be next.
Okay.
Well, this is Eddie.
Yeah, I thought I'd bring in this. This is a new robot from Parallax. This is not homebrewed at all. I assembled it, but that's about it. Parallax, for those of you who know, the makers of GoBot, propeller chips, basic stamps. They've come out just recently with this larger platform. They have some others that are a little similar. That's designed primarily actually to run the Microsoft Robotics development studio. Similar in a lot of ways, configuration-wise and so forth, to what Ross has and the TurtleBots and so forth. I think this is sort of Microsoft's answer to it. Differential drive, wheel encoder. The main piece of this thing that's really pretty interesting is the board. So it's got a pretty hefty motor drivers on it. Analog input output, digital input output, programmable switches, power, good output for various voltages of power. The Connect, obviously, Microsoft, so it's got to have a Connect on it. And so far it's been pretty good. So I've been playing with it just a little bit, mainly writing software at this point, so I haven't had a chance to get too far into the hardware. I've had it for about a month now. On loan, it's expensive. It's about $1,300, plus the Connect, plus the laptop. So some folks have been on the list earlier asking about the casters on the bottom. These are pretty nice aluminum casters that the Parallax has put together. They do a great job with the machining on this. It's very, very well, very tightly built, very well machined. Good parts, good experience assembling the whole thing. So anyway, a lot of fun to play with. I'll set it up afterwards and roll it around if you guys want to take it.
Is this a variation of the standard kit? Because I thought it came with the pins all the way around.
No, it's 2 sonar, 3 infrared on the front. You can rotate them a little bit, but no, it's nothing on the back. It's really designed, I think, primarily. It's based on Microsoft's reference platform design. So Microsoft, with the recent release of the new version of the Robotics Development Studio, came out with a mandate saying, here's a platform design we recommend vendors try to create, build off of. The sensors, the Connect, the differential drive, and so forth. And they got Parallax to agree to come out with their first real implementation of this. I think the long-term goal, of course, is additional vendors to come out with platforms as well. And then software-wise, Microsoft has provided all of the abstraction layers necessary to actually integrate with the various components. So, from a programming standpoint, which is what I do primarily, it's really a pretty good experience. Because all the hardware is abstracted away, which for me is the hard stuff. So it's a good platform.
What's the glue that puts the different modules together?
The glue, as in.
I think you're talking about the board. There's a board.
Yeah, there is a board. So it's running a propeller chip. There's firmware that Parallax.
From Microsoft in particular, I mean, they're.
So Microsoft is talking to the firmware that Parallax has exposed. So Microsoft exposes what they call a generic contract for their service. Here's a generic differential drive contract. Here's how you as a vendor who wants to build something would implement that contract. And me as a programmer just programs against the contract. I don't worry about the hardware. So Parallax had to do all the work to create the firmware that is going to speak Microsoft's language. I think someone on the list, I think it was Patrick, who worked a lot on Ross, pointed out there's nothing to prevent someone from then creating the firmware on the same exact hardware to run Ross. It's just that they've done it first to support the Microsoft contract.
Okay, so they've got a driver for that board and obviously the Connect. They've got something for the sensors there, or is that part of Parallax's?
Well, so Parallax has to expose all the raw data, right?
Mm-hmm.
And Microsoft says we expect the data to come in this format. We understand these raw numbers, and it's Parallax's job to expose that through their firmware to the Microsoft contract. Then Microsoft, as long as the data comes in a way we expect it, as long as a sonar sensor returns data in this way, we don't really care where it came from. We'll consume it. We'll expose it up with the higher level programming layers.
Somebody signed up to do a talk on Robotics Studio.
That was me.
That was you.
Yeah.
Okay.
So
that's coming.
Yeah. So in May, my goals. I have a project I'm building on this right now. By the May timeframe, I hope to come in and actually show what I've created. I'm about halfway there.
What's the interface between the Parallax board and say a laptop? Is it Ethernet or wireless or?
It's USB, but it's a serial. Serial over here. Exactly.
Okay, good. Thank you. What's your question?
Carter, what was your question for
What's
this?
your question, Carter?
Yeah, well, there's a camera on the top and then some little smaller cameras on the back.
Good question, Carter.
I want to know if it had a camera.
Okay.
All
By the
right.
way, we encourage children to sit up front. You get a better view.
All right, well, this is another version of Big T. We've been really trying to get the arm to go up and down and the hand to work. And we actually got the hand open and closed finally. You know, just a little, of course, it jams every now and then because when you're with people.
We'll squeeze a little bit
And then also, the other thing we've been really working on is trying to get the arm to go up
without binding.
without binding. And we think we figured that out. We're going to probably put a counterweight on it.
Right
A couple
now,
other things just to get it to work. When you put any kind of weight on it, it seems to want to struggle a little bit.
we use like a chain link and two eye-loop bolts. It kind of, so it's all rounded and there's no sharp edges on this. We're getting there a little bit.
Our
A new head.
own challenge we want to do someday is we want to be able to take something off of one table and just move it over and put it down on another table. We think that'd be pretty awesome for us. And then of course we're thinking about putting a Connect on top.
And this camera here is hooks up to like a television set somewhere else where you can see up to about 100 feet wirelessly. So you gotta get some telepresence with it. And yeah, we're getting a little stable. And then we have Ross Diamondbacks on this computer. And right now we're trying to get our Android hooked up. There's a server problem or something. But once we get that, we'd like to maybe try Ross Java or something else.
And of course, and then we're going to be changing the body too. So it kind of looks funky right now, but we're
We got a
working on that.
fiberglass body we're making.
And it's just taking time.
So robot games, we should be all
I think
set.
that's the hardest thing for us, really. Hardware stuff.
I was thinking about a year, because we've been at like last year.
So
and then
that's it for now. So, you know, it
That's
has
a
its little.
That's
Got a new head.
Hey, we kept trying
Hey,
too, buddy. That's
I
like the
actually
fourth
thought
head,
about
you
that
know?
too. So
It's-
I almost had two of them.
You want to go next? There you go.
All right, so show people how you turn your robot on.
Daddy, let you stand on the table like that.
You want to tell them what it is?
It's a Lego robot, and pretty much made of Lego.
All right. How do you control it?
Well, we control it with your phone right here. And
There you go. Tap it. Tap that.
do it, and
Tap that.
go.
Hit connect.
Next.
Go.
There. Go. Good.
How is it? How is the phone talking to the robot?
It has a Bluetooth.
Bluetooth radio. That's right.
Bluetooth radio.
Let's try.
Yep.
There you go.
That's how you do that.
All right. Show them how you drive it.
Yeah.
So how do you control it? Can you show people what the screen looks like?
Well, the screen looks like it's
Hold it up so they can see it.
good.
So it has a face.
Yeah.
And
It
then,
does.
and then how do you control it?
Well, you control it with the little Bluetooth.
Okay. All right. We'll drive it around.
Well, okay.
just put it on the floor so you can drive it more.
Well, it's gonna drive like that. That's how it. And one more question.
You have a question for your own robot?
Also, it's named. What's his name?
You named it.
Well, what's his name?
You just called it Lego Bot.
RoboBot.
All right. Thank you, Carter.
Yeah, thank you. Are there any more robots on this side? Did I clear off the right side here for me? Here, now we're going to start working down this side. Cam, Ted, okay, fine. Okay.
Gotta finish building it. So this is Homer. I lost my mallets the other day, so I had to get creative. I'm gonna bring Homer to the Barbots this weekend for a little musical entertainment.
All right.
And I've added a head.
He knows one song?
He knows 2 notes. We're working on the third, then we can play the blues. And as you can see, Mr. T's got a new head. This is, yeah, let's see if I can make it through here. So I'm going to make this into the rock bot. I've got a couple of robots that I perform with the band Black Mass. They've got the skeleton and the crow. Well, this is going to be the rocking head. Eventually, I'm going to have the head rocking like this, and I'll get the arm to come up with the rock signal every now and then. So this is a Mr. T from John and John, and like I say, I've replaced the head on him. So. He's got the whole Springy is probably one of our oldest robots. Springy's 13 years old, and last year she didn't get to make it to the meeting, so this year, or this month, there she is. Springy thingy, it's a Burning Man robot. Springy survived 6 burns. The goal being to leave the event with a functioning robot that grabs the 38 kilohertz Pringles can. All right, that's it for Springy. Give it up for our Homer. Homer is the Jonathan Retraining robot. Thank you very much. Come to Barbots this weekend in San Francisco.
There are some Barbot flyers over there on the table.
It's the same night as Vernal Equinox.
Okay, Alan. While we're waiting here, congratulations to Alan Fetterman for getting his 4th article in the Servo. How many people have done 4 or more articles? Raise your hand, Bill. Okay. How many people have done 5 or more? They were 4 and 4 is our maximum. Good job.
Okay, we're set the bar.
Yeah, set the bar.
Michael Moose.
That's the Micro Moose. Batteries eliminated this time. I've been working on a jaw, which you see is a little bigger than the robot now, so not have a problem that way. What I did was add a tilt servo in addition to the jaw servos, and I've actually operated it with the RC, which I didn't bring tonight. And I can grasp a can and tilt it a little bit,
As long as it's almost empty, there's a weight limit there, but that's okay, that was part of the plan, so. Maybe next meeting I'll have the rest of the stuff connected back up again.
Okay. Tim.
Been some traffic on the list recently on this. It's the Asus Sextium Pro. It's same technology as the Kinect. Microsoft did not invent the technology. They simply provided middleware and packaged it. So the primary advantage on this, it's obviously much smaller, lighter, one cable. But other than that, it does the same thing.
What about drivers?
The drivers are available both for Windows and Linux. They're open source. So, in fact, that's the ones that originally broke the Kinect. And Open and Microsoft had to kowtow and say it was okay. Now they're apparently backing off on that, trying to make their next version of the Kinect active. So, another reason to go to it.
Tim, is that just a 5-volt USB source?
I just plugged in the USB port on my computer and it worked.
What's the price comparison?
160 from Newegg. List is 200 for this particular version. They have a version that doesn't have the RGB camera and does depth only. That's somewhat cheap.
You have a question? Or you have a robot?
Yeah. No.
Question, okay. Announcement, got it.
So, about 3 months ago, I got a Nano ITX board from this club. I don't know who it was from. Anyway, I added memory and a PSU and a wooden enclosure. It looks like an old-fashioned radio. Anyway, I am giving it back to the club because I got a laptop. And Arvis didn't work on this because of the graphics drivers. So,
is there anybody here, who here would be interested in going home with a mini ITX card and bringing it back as a robot? We're trying to bring it back. I think we've got a taker here. Oh, sorry, is that another hand I saw there? Because then we'll have to raffle it off. Arm wrestle.
No, well, you can hand wrestle too.
Yeah, you can hand wrestle, okay.
Rock, scissors, paper.
What?
Rock, scissors, paper.
No, we're not going to do that. Okay, you're going to call heads or tails on it. Okay, call. Come on up here and take a look at it. Okay, sorry.
Don't forget your
Okay. So, let's see, where are we doing with the Ted? Yeah. Let's go for it.
So Brandon took home Willie the Turtle Bot.
Willie's in the box over there.
He got all excited, made me excited, that's for sure.
Yeah, we had a lot of fun with Willie, so brought him back, and I think within a couple days.
I have to explain what I did. Willie is a turtle bot that was donated to the club by Willow Garage. Looks a lot like Alan Fireman's, but he's in the box. And the purpose is we lend Willie out to members of the club to play with, and then they bring him back and tell us what their experiences are. You're noticing more and more people running across in the club. That's the whole purpose of this thing. So, nothing.
All right. Yeah, so we got Willie. So this month was our month with Willie, and ran him through his paces. So within a couple of days, we had him running around the office. We had him making maps, and we could had a lot of fun asking him to go to particular positions in the office and watch him navigate around obstacles. So,
yeah, I'll let you know.
There's some forward.
Rat's nest.
We also got them to follow each other
too.
He's on video.
And here's Willie. So yeah, so we got these two, as Ted will talk about, we got them to follow each other around, and if you're interested, later we could get that demo working again. But it worked great. And one other thing, I updated this, had Diamondback ROS on it, so I upgraded it to the latest electric.
You got it to work.
And I got it to work, so it has the latest, and it might even have some extra repositories on there. So, experimented programming, created some ROS nodes of my own. So, anyways, it was a lot of fun.
And so Brandon's messing around with Willie, and we were like sitting there going, well, we had all the parts, so we thought we should make Willie a girlfriend, so that way, when Willie decided to go back to the club, we still had a TurtleBot to play with. So I cut out acrylic discs instead of buying the other ones. And my cutting bed on the laser cutter is only 12 inches wide, and Willie's discs are 12 and a half. So I made new files to support doing that. So if you wanted to cut out your own TurtleBot discs at the tech shop on their laser, I have files now that will work with CorelDRAW that you could just load on the laser there and cut out new TurtleBot pieces out of acrylic that will fit on their thing. So if you, afterwards or whatever, if you let me know, I could email you the files. You could just, I have them in CorelDRAW form that I'll give them to you, and you can just cut them out and go wild. And then, so then we all had this laptop too that I had used for RoboMagellan last year, and Brandon diddled with it, and the next thing you know, like, he pretty much cloned up Willie and put him over here, so it was really easy actually. I was pretty blown away at how quickly, once he had Willie going, how quickly it was to build this. It was just a snap.
Yeah, actually it was nice having Willie because we had all the working parts. So to start with, I just used this laptop on Willie, you know, and got it working on Willie, and then we said, okay, we know it works over here, so now we should be able to get it to work on that.
So we were able to just literally like take one laptop off of one and put it on the other, and it was interchangeable. And it was really, as opposed to starting from scratch, like I read all through a lot of the wiki page that the club had generated on all of the work that Alan and these guys had done to get Willie working in the first place. And it was apparently somewhat painful the first time through. If you want to
repeat the same exact mistake.
yeah, exactly. And but once but I guess the point is, if you want to build a TurtleBot, take Willie home and use him as a reference point, because it went way faster because of all the work that the other guys in the club had done already. And then the other item that we have a little demo. So we got the ROS launcher and everything loaded up on a smartphone here. And so the Kinect is it working? Oh, it crashed. No, it's working. The Kinect is streaming video.
Is that mounted right?
What?
The zoom lens?
Yeah.
It's upside down.
Is it?
I think
No.
that's the way.
No, that's right. It's working. And actually, with the zoom lens on it,
It's not in the right spot.
is it? It still works. But with the zoom lens on it, actually, with one of these zoom lenses on it, you can actually see the posts. So when you're driving it around, you actually have a reference point. But there's video streaming from the Kinect to the laptop, to the Wi-Fi, to the phone, and it can view the video of what the robot sees, so it sees all of you. Obviously, if I move it around, it changes where it is. Yeah,
That's the Willow
Can you put it on the
Garage
floor
app.
and drive it around?
Yeah, this is the this is the Willow Garage app, and it's in the Android App Store, and you can just download it, and if it's connected, you put the IP address in and everything, and next thing you know, you have remote control, and it's totally teleoperated through your phone.
All right. If you get Willie, I think just the fastest way to get him driving around is to use the Android app, so you can get it up and running around.
Yeah, and it's just in the Android marketplace. You
called
have to download.
TurtleBot?
What?
Is it called TurtleBot?
Just do a search for Willow Garage in the Android market, and you'll find there's like an app launcher.
There's the
App
app
chooser.
chooser. You have to
Yeah.
install the app
App
chooser
chooser and a tele.
and the teleop app,
Right.
and then you'll be set.
And then in that same place in the store, there is other apps that show up in the chooser. So there's the teleop app, but there's also another app that will make it move like a cow. And then the other one is the follower app that Willow Garage did that makes it follow you around. You can launch it and from the chooser and it makes you follow.
I think Tony wrote that.
Oh, did he?
Tony Pratt
Oh,
can't.
without the thing. Okay, well, if I pull it off, it'll probably do it. There we go. So, here's all of my legs. And this is just one of the apps that they, Willow Garage wrote, Tony wrote. And it just follows your legs around using the Kinect, and it's just built in. So, and that's in the TurtleBot stuff already, and it's easy to launch it if you just have it there. If you get too close, you can back up, see?
Can you play the example?
What?
He can move.
Then you can move, yeah. Right. So there's moving, chasing, and teleoperation, and you get all that pretty much for free. It's just there. I think that's it. Okay. Thanks. Yeah. Sure. Yeah. Right. You can do that, yeah. This part is super easy.
Yeah. By the way, we should find out who's taking Willie home tonight.
John and John.
John and John are taking Willie? Okay.
You got space in the car?
Okay.
You're volunteering. Thank you. I appreciate that.
All right.
If it has follower, I'll take video downtown.
So I just have a brief TurtleBot mod to show. 1 second, Carter. We did a couple things different on here. To save weight, I got rid of all the platforms except for one. So there's just the base. Then I added an arm. This is the most significant mod. So Melanie at Willow Garage has this on loan to me. You can get this arm kit from HBRHomeBrew, assembled or unassembled. Carter's holding a PS3 joystick, which is another way to drive it.
Well, it also runs with a program. And it's pretty much expensive.
Thanks, Carter. So if you don't have an Android phone, if you're an iOS user or Windows Mobile user, but you do have a PS3 at home, that's another out-of-the-box thing that the TurtleBot can do. You just plug in a little Bluetooth dongle here. These are like $2, and then you can drive the robot with that. The other thing I did was put the laptop in a new spot here, which kind of hits the center of gravity. And then I also had a zoom mounted on here to see up close. I did some measurements in RViz where it seemed about 18 inches away. You can get good, you can get good data back from about 18 inches away if you have the zoom mounted on there. So that should mean that the end of the arm could be picked up by Ross so that it's seeing what it's actually picking up and then moving it. And then I added a Hikoyi laser. This is like a $1,200 laser that is used for mapping and localization instead of the Kinect. So you get very, very accurate, high fidelity maps that work in big spaces where the Kinect can't see. It works natively with ROS. And in fact, the latest version of TurtleBot code that was just being pushed out a week ago, or 2 weeks ago, has native support to plug in a Hikoyi, as well as the other PrimeSense sensor that you showed off. So you can go PrimeSense or Kinect or Hikoyi laser, and that's all in the native TurtleBot code.
Very good.
So hopefully this will be running later today.
Okay, I think if there's a theme for tonight, it's TurtleBot is winning. So I actually lost count. I think we had 5 TurtleBots, at least 4. So a lot of excitement with TurtleBots, and I expect that to continue. I have a mini goal. I would like there to, by the end of this calendar year, I'd like the club to have 10 TurtleBot robots, or not necessarily made by Will Garage, but our clones running. Okay, so let's see if we can meet that goal. Okay. Are there any further questions? No. Okay. Any further robots?